Hello everyone. In this video I'm going to solve an example of labeling problem when we have n distinct objects and k distinct labels and we want to label the objects by these labels such that each label gets a certain number of the objects. But let's see what is the problem itself. Problem has two parts. Part A says, in how many ways can 12 different books be distributed among the 3 students, Andrew, Betty, and Charles, such that they each receive the same number of books, meaning that while they will receive each one will receive 4 books. And part B says that we have 12 different books and we want to distribute them among the same students, Andrew, Betty, and Charles, so that one student receives exactly 5 books, another receives 4 books, and the last one receives 3 books. Well, let's start with the general formula. When we have n labels, n distinct objects, and we have k labels, and we want to label these objects such that n1 receives label 1, and 2 of the objects receive label 2, and k receives label k. And well, based on the numbers there, we know that n1 plus n2 up to nk should be equal to n, because we want to label all of these objects. Then the number of ways we can do this is given by this formula. You have n, choose n1 for label 1, n2 up to nk. Well, the formula for that is n factorial. Down here's n1 factorial, n2 factorial, up to nk factorial. And if you look at the first question, first we have 12 different books and we want to distribute them. So that's the number of objects, and we want to distribute them among Andrew, Betty, and Charles. So we have 3 different students and we want to give these books to these students, or in other words, we want to label these books by the owner at the end. So this is basically labeling. But there is a condition such that all receive same number of books. Basically, we want 4 of these different books receive label Andrew, 4 of them receive label Betty, and 4 of them receives label Charles. Well, then everything is there. We have 12 distinct objects, books, and we want to label 4 of them by Andrew, 4 by Betty, and 4 by Charles. Their names, I mean. So then this is 12 factorial, 4 factorial, 4 factorial, 4 factorial. That's it. Part A is done. Part B is a little bit different this time. Well, we know that one student would get 5, another would get 4, another would get 3. If we knew that, for example, Andrew is going to get 5, Charles is going to get 4, and Betty 3, then the question was exactly same as before. We have 3 labels, and we know that we want to label, we have 12 distinct objects, and we want to label 5 of them by Andrew, 4 of them by Charles, and 3 of them by Betty. But and then, well, the number would be 12, 5, 4, 3. But wait a minute. We don't know, in the question, we don't know who is the one who's going to receive 5 books. and we don't know which one of these three is going to get 4 books and which one 3. So this is where you have to see that this is not only labeling. Well, then how we can relate this to labeling and try to solve it? Well, what I can say now is that there is 2-step job here. Now, first I make a pile of 5, a pile of 4, and a pile of 3 of these 12 different books. Then I have basically labeled the books by number 5, 4, 3. The books with label 5 goes to the pile 5. Books with label 4 goes to the pile with 4 books, and books with label 3 goes to the pile with 3. So basically, step 1 is that this goes pile 1, pile 2, and pile 3. This way, we have found the number of ways we can make piles of 5, 4, 3 books out of these 12 different books. There's one important point here you have to notice, that making piles, teams, groups are not labeling by themselves unless they have something which differentiate them. In this case, the number of each pile or each group is different, so that the number is basically itself a label. So first step, we have 3 piles with different number of books, and well, based on that general theory, we have this many of ways we can make these piles. But we are not done. We haven't given these books to the students. Well, now I have 3 piles, 5, 4, 3, and I want to give them to 3 students. First student, Andrew, has 3 options, either pile 1, 2, 3. Next one, Betty, has only 2 because one of the piles are already given, so it's 2, and the last one is 1. Charles has 1 option. Basically, this is the number of ways I can distribute these 3 different piles among 3 different students, such that they get exactly 1 of them. So that's the permutation. Well, I made the piles this many ways. I can distribute them among these students in this many ways by fundamental counting principle. You have to multiply these 2, and we are done, because we distributed the books to the students, among the students, with this condition happening. Again, note that you have to be careful always. All these conditions should be there when you're using labeling. Objects are different, labels are different, and the number of ways we want to label them are given, and they add to n. Then you can use this formula. But sometimes questions like this, we cannot interpret the problem into one distribution, one labeling problem. We have to make at least 2 steps, such that one is labeling, in this case, making piles of different number of books, and then the second step is distributing.